Eh, Now on stage already, Rolf, who quickly came up in between, the audience might have seen. Rolf was quite surprised that he is on stage. Rolf Meyerhans is working at Norbert Schläfli Maschinen, and feel free to go ahead with the screen share, dear Rolf. And this is coming up and looking great. So you can see highly scaled gravure printing is the topic of the presentation. Rolf, everything is looking good. Sound is good, camera is good, slides are in full screen. So with that, the stage is yours.
Okay, welcome to the audience from Switzerland. And in the next few minutes, I would like to explain the high-scaled gravure printing project. Uh, so, my name is Rolf Meyerhans. I'm responsible for the technical parts, and from the technical point of NSM Schläfli, I'm working since nearly 2 years for NSM Schläfli. NSM Schläfli is a company located in Switzerland. We are founded in 1985. We are specialized in developing customized systems for multifunctional printing and in the sheet-to-sheet and roll-to-roll systems. In the last 30 years, we have developed different printing technologies, gravure printing, and also integrated this in roll-to-roll machines, also drying technologies, so that we have the bunch of technology where we work together with different companies. They supported us to integrate this technology in our machines. About the highly scaled gravure printing, it's a project, a Swiss project with the ETH, the EPFL, NPA, and also from the industry side with 3D AG, and part of us is the development of the gravure printer for integration in the machine as located in NPA in Düppendorf. Around this is a project in the strategic focus area and advanced manufacturing, and that's the setup about the project. What's the objectives of this project is to reduce the line width in the gravure printing to less than 2 microns with a print speed of 1 meter per second for A5 format. Actually, we are in a feature size around 15-25 microns with flexogravure printing, and on the right hand side you see the arrow where we would like to go. It's a line width to less than 2 micron, and to achieve this we have to do different improvements around the gravure printing process. For this we have different activities, and these activities will be done by the participants of the project. That means a PFL will working on the ink formulation. This is for the filling, for the doctor plate process, also for the transfer. So we have also the spreading, and also in the end to check what's happened with the substrate and also with the printed structure. Is it this what we have to expect? For the side of us to modify the gravure printing unit, we need a pressure and position controlled printing cylinder to the substrate. That means we have to get out the system data, also the doctor blade angle and the position of the doctor blade. And for the doctor blade, also the force management between the cylinder and the nickel shell. That's around the printing process, and for this we have